Okay, so for question number 2, it asks us to describe the events taking place in the left ventricle and aorta during the cardiac cycle. So the best thing to do for this is I've input this graph right here that kind of represents a bunch of different things, and there's a lot of information on it, but what I'm going to do is talk through each stage of the cardiac cycle and talk about what happens in the left ventricle and the aorta, in terms of how their volume and pressure changes and things like that. So first we're going to start with this little section right here, which is isovolumic contraction. And so as we can see here, this is called isovolumic because here, if we see this ventricular volume represented in the red here, we see that it does not change. So when the volume does not change, that's what we call isovolumic. But the ventricular pressure, labeled here in blue, will dramatically increase. We're right around 0 here at the beginning, but once the ventricles begin to contract and we have this large increase of ventricular pressure up here to about 80. And that is what happens to this isovolumic contraction. So here in this stage as well, we can see that the ventricular pressure will become greater than the atrial pressure, and that will cause that valve to close between the atria and the ventricle. And so that will cause this first sound right down here, which we call the lub sound. So now this second stage right here, from here to here, we will label ejection. And so during this stage, we will go ahead and talk about each one of these things here. So the ventricles will contract and the pressure will continue to increase. But what happens is that the volume will go down. Here in the red, we see the ventricular volume will come down, and that is showing that the blood is traveling from the ventricles into the aorta to go throughout the rest of the body. And that is why this aortic pressure up here in black, after the aortic valve opens, the pressure will increase with the blood that is flowing from the ventricles into the aorta to go to the rest of the body. So here we have at the very end, this is what we call isovolumic relaxation. And again, isovolumic because here we see the ventricular volume does not change. And so what happens here is the pressure of the ventricles will continue to go down because the blood has flown out of the ventricles into the aorta. And so what happens is we will have the ventricle pressure will go below the aortic pressure, and as soon as that happens, the valve from the ventricles to the aorta will close, and that is what causes this second heart sound, which it can be defined as dub. Is a common way that we identify that second sound. And so once the ventricle pressure drops below the aortic pressure, that valve will close and cause that sound. And here we will have what we call the diacritic notch, which is kind of a significant part when looking at a graph like this that shows the point where the aortic valve closes, causes the second sound, all while the ventricular volume remains the same, but the pressure of the ventricles continues to drop and continues to relax after the ventricles have pumped the blood out of them into the aorta. So this next section here in diastole, we will label rapid inflow. And here we see what's happening is the aortic pressure is going down because the blood is now out of the aorta flowing through the body. The ventricular pressure has come down as well because the blood has flown out. But we're starting, as we're relaxing, the flow of blood into the ventricles is passive. So it comes into the atrium and into the ventricles passively and can happen during this relaxation phase. So that is where we see this rapid inflow, rapid increase of ventricular volume. About 70 to 80% of the ventricles will be filled up with blood during this time. And this is kind of a relaxation phase where the blood will come back into the ventricles to begin the process again. This next section in the relaxation is called diastasis. And there's not a lot going on in here. We just see this relaxation continuing to happen. Because the ventricles are reaching their capacity, there is not a lot of change in the volume. There might be a little bit of blood coming back in. No change in ventricular pressure, atrial pressure. This is more of the relaxation where the heart is gearing up to pump again and start the process all over. And so this last section of this diastole, we will actually label atrial systole. And so what happens here is there will be blood coming back into the heart, and the atria of the heart will contract, which will pump more blood into the ventricle, and that is where we see this increase in ventricular volume. So that will kind of top off the ventricles, and we see a little spike in the pressure as well right here, and that is gearing up the heart to begin ventricular systole again. So this change in pressure and change in volume will then cause here we see what kicks off another cycle of systole is the ventricular pressure becoming greater than the atrial pressure, which will start the entire process again. So this is the different stages of the cardiac cycle and what happens in each one, having to do with the pressure and volume of the atria, aorta, and ventricles, as well as the heart sounds that we're able to hear. Okay, so for the second part of this question, it asks about the pressure volume loop. And so this is of specifically the left ventricle, because that kind of explains the cardiac cycle and how blood pumps through the heart. And so I'm going to, again, use another little graph here, but I'm going to draw everything in. So on the x-axis, we have the left ventricular volume, and on the y-axis, we have left ventricular pressure. So we've kind of got this shape here that I'll label and kind of make sense of, that will show the cardiac cycle in a different sense. But first, what we know here is that this distance from end to end of this loop is the stroke volume, which contributes to the cardiac output. That is one of the factors in the calculation of cardiac output. So first, I'm going to label this section here. We'll label this here, this section where the volume and pressure are slightly increasing. Label this as A. And so we'll make kind of a key over here to kind of talk about each one of these things. So with A, we know that this is diastolic filling. So we know that the volume of the ventricles is increasing, and therefore the pressure is increasing. And so that is for this first section. So then I'll go ahead and label this kind of intersection, this change right here, and we will label this M. And so this M will be the mitral valve closes. And if we remember, that is what happens when the ventricular pressure becomes greater than the atrial pressure, which will be what starts the contraction. So now I will label this section here. This will be B. And this, as we know, is isovolumic contraction. So we see that the volume is not changing, but the pressure is increasing, and that's what we know is happening when the ventricles are contracting. The smaller the area that the ventricles are holding the same volume, the pressure will increase. So now to label another intersection here, I'll label this one AO, because we know here this is where the aortic valve opens. And this is when we will have the blood from the ventricle that is being pumped to the aorta. The aortic valve will open so that the blood can travel to the rest of the body. So now this section here from AO all the way here will be labeled as C, and we will call this the ejection section. So this is what happens when the volume of the ventricles will start to go down as the blood is leaving the ventricles going into the aorta. As we know, AO is where the aortic valve opens, so the blood going from the ventricles to the aorta will be what's happening in this ejection section labeled C. Here at this other intersection, I will label this AC, and this will be aortic valve closes, and that will be what happens after the blood is pumped through the aorta and the pressure goes back down. So the aortic valve will close after the blood has been pumped, and everything will be relaxed, getting ready for the next section. Here we will label this section D, and here we have another isovolumic, but this will be relaxation. Because we see the y-axis representing pressure, the pressure will be going down, but the volume will be staying the same. Here, right back to where we started, we'll label this VF, with our final label being ventricular filling. And this is where it begins. So this is kind of the cycle, the loop that represents a cardiac cycle. From A, we have the filling of the ventricles. We see the volume and the pressure increasing. When the mitral valve closes, meaning that the pressure changes, we will have the blood, the pressure going up as the ventricles contract and pumping the blood into the aorta at this AO intersection. When the valve opens, blood can go to the rest of the body. After that has happened, the aortic valve will close, which will cause the relaxation of the ventricles. The pressure will come way down to the point where the ventricles will begin to fill again. And this whole loop is what we call a pressure volume loop that is representative of the cardiac cycle from the perspective of the left ventricle.